Cool. All right, we're recording. Claude, you got control?
Let me see. Yep. Sure do. Okay. Hey, how's everybody doing tonight?
Doing great, Claude. How
Doing
about
good,
yourself?
doing good.
Okay. All right. So what we're going to do, we are basically going to connect PC3 and PC4. All right. We're going to connect them through this here network, through these here two core switches you see in the center. But here's the caveat. We're going to have one of you guys is actually going to apply a DHCP server to one of these here layer 3 switches. Okay. So what's going to happen, I'm going to have you guys check on the basic stuff that we've been going over with layer 2, making sure that our PC is connected to the proper ports as that it's supposed to be, making sure our switches are learning the MAC addresses. All right. We'll be checking these ether channels, and what we'll be doing is we'll be checking to make sure that they're trunking so that they can carry our VLANs across from end to end. Sounds good, everybody?
Yes, sir.
Yes, sir.
Okay. All right. So let's get this started off. Let's see who we got in here. We got Zamir, we got Patrick. I see Kelvin in there, Carlos. Okay. All right, Zamir.
Yes, I'm here.
All right. So what do you remember about layer 2? And we want to confirm if our PCs are connected to our access switches properly and that they are learning the MAC address. What do you remember? Talk to me about it.
As far as learning it, so with layer 2, when you say that, what comes to mind for me with layer 2 is pretty much when the switch is sent out, if I'm BDP, I don't want to get it wrong, but when they send out the signal, that's a way that they determine the root bridge, but also learn the MAC addresses of all the switches on the network.
Okay. Okay.
So that's the way to confirm that the MAC addresses, because it's layer 2.
Okay. So where do we find those MAC addresses at on the switch?
As far as I mean, like by the ports that it's connected to, like the port to tell the MAC address of that device. You mean like if we were physically? You mean we looking at it, or if the
If we're on the switch, where are we looking at to find MAC addresses?
on the back of it?
The MAC address, the MAC address table.
Oh, right.
There you go. All right, so let me see.
Okay, so let's while Claude is setting that up, let's take a little bit further. Zamir, I'm staying on you. So we're checking the MAC address table. What are we confirming on the endpoint?
When we checking the MAC address table?
Yep. When we're checking the MAC address table on the switch, what are we confirming on the endpoint, the actual PC that's connected to it?
Oh, that the MAC address is showing up. I'm not that they're connected. That information. I'm not sure. I'm what I'm remembering is that I guess the information should be on there in the MAC table. So you're just trying to verify that that switch I guess knows or is connected to that client, that PC.
Are you asking me or are you telling me? It sounds like
I'm telling you.
a question at the same time. Okay.
It's
all right. So let's be engineers for a second, okay? So yeah, so let's be engineers for a second. So if, right, we're talking about layer 2, right? That's where switches, we haven't configured anything for this to do, layer 3 or anything multi-layer functionalities. It's just strictly doing layer 2. If we're going to check the MAC address table, right, we're at layer 2. It's if that's the method of communication, what are we going to confirm within the MAC address table that it's communicating with that endpoint, with PC3? And why? We're still at layer 2. By the way, it's not a trick question.
Looking for MAC address.
What are we confirming on the endpoint?
Is this for anyone?
Question for anyone?
Hold on. Nobody else help him. Just Zamir. Zamir. Zamir, you there? Did we lose him?
My bad, I'm here.
on,
I didn't
hold
realize I had went on mute. Yes, I'm here. I was saying that it's connected
Okay.
to that switch. Did you? I don't know how long I was on mute, but
It's all good. So what are we checking, right? What are we confirming on the switch? And what are we looking at on the endpoint to confirm that the switch is communicating with the endpoint or PC3? Keep it simple.
I'm not sure.
OSI model. OSI model. Come
Okay,
on.
so
I
from
know you
level
know it.
2, it's checking. I'm not sure, maybe the frames or the port just to see, like from the.
Okay.
I'm not
hold
really
on.
sure.
Hold on. Let's. Nope. Don't
Oh.
you tell me you're not sure. I know you
Okay.
know it.
I'm sorry.
So OSI model. I know you know the OSI model.
I do.
So layer 1, we're checking physical connectivity, correct?
Yes, that's all your physical
Perfect.
components.
Okay. Perfect. So with that being said, right? Claude said you're going to go ahead and take a look at the MAC address table, right? What are we confirming there, right? What are we looking for there, and what are we looking for on that PC to make sure there's communication happening, right? And again, we're still at layer 2.
Yeah. I mean, besides the MAC address, what's else at layer 2? The switches. I'm not. Yeah, let me see. What are we confirming on the PC?
What are we confirming on the switch, and what are we confirming on the PC? So that when we go back to the switch, we can confirm that communication is happening. And again, guys, remember, Claude's going to keep it simple. I'm going to throw out the technical terms to you because whenever you guys go into these interviews, you guys are going to be hit with this as well. Probably even harder. Keep it simple, Zamir. I know you know it.
I'm not sure. I know that frames are at the level 2. So
Okay.
I mean, but I thought it was. So are they checking to make sure that I'm not? I don't. Let me see.
It's okay. So let's walk through this. Me and you are engineers, right? So
Right.
at layer 2, right? So layer 2, right? What are used to identify frames within layer 2? They're not IP addresses. They're what?
MAC addresses, right?
Okay, they're MAC addresses, right? So out of the 3 major functions of the switch, there's 2 major functions that the switch does. Can you tell me those 2 functions in regards to MAC addresses?
Let's see.
And I'll give you a hint. We already know about spanning tree. So what's the other 2 major functions that the switch does?
Oh, so a switch, we know about spanning tree forwards information. I mean, they forward information, right?
Right. So we know about spanning tree. What's the other 2 functions of the switch at layer 2? what does it do? Whenever it receives a frame.
Yeah, it
what does
finds
it
out
do?
which device is connected to it that has that MAC address on. You know, it makes sure, because well, the frame will have a MAC address, so it makes sure that, you know, it's the right switch, like it's forwarding to the right client or PC.
Gotcha, right. I get what you're saying, exactly, right? So based on the source MAC address of that frame, it learned that MAC address or that endpoint in the MAC address table, right? Is that what you're
Right.
saying,
So
right?
anytime
So
information
that's one
comes
of
in
the,
this, oh yeah, go ahead.
no, keep going, keep
I was
going, I'm
saying
sorry.
anytime information comes in, is looking for forward information, you know, that switch will acknowledge that, you know, that MAC address, you know, goes to them. That's the end device is connected to that switch.
Perfect, exactly. So it knows where that PC or that endpoint lives on that switch because it learned it, because it sent out a frame from that port. And so again, one of the major functions of that switch is it learns MAC addresses based on the source MAC address. So correct. Now, we have that, right? We have that information, we have this there. We don't even have to dive into the second one. With that being said, everything that I just talked about, as far as me and you, us both being engineers, talking about the function of a switch. Back to my question. What are we checking on the PC and what are we checking on the switch to confirm that communication is happening between both devices? And again, we're still at layer 2. We're not going to layer 3 yet.
We'll be checking to make sure they're communicating.
Yep.
I'm not sure. I mean, would it be like, I'm not sure. Would it be like command line, like saying if it's, well, you say we're not doing no network or nothing up, just layer 2.
We're doing layer 2. Think about, and let's slow it down here. Think about what we just talked about. The 3 major functions of that switch. It has to learn MAC addresses based on the source MAC address. What is the switch doing? What does it need to do?
Be able to forward that information.
PC3.
Yes.
It needs to learn the MAC address of PC3, right?
Right.
Perfect. Okay. So for us to confirm that and to make sure, hey, the switch is learning the MAC address of PC3, what do we also need to check on PC3 to compare and contrast the MAC address table and to make sure that PC3 is learned by that switch? What do we need to check? Now, this is a trick question because I just gave you the answer in the question.
I mean, I'm feeling like maybe the MAC address table, but that would be just for the switch, right? So
what do we need to check? Maybe it's highlighted on the screen.
yeah, the MAC address.
Yep, on what?
On PC3, right? To make sure that it's communicating with the switch, to make sure well, I kind of said that when I was saying make sure in the table it's on there, but I guess I'd articulate a lot better. But checking the MAC address of PC3 to verify that it is in the table on the switch, that the switch has learned it.
Exactamundo. And guys, remember, Zamir, you may have said it in your way.
Yeah, but that don't.
Not gonna work whenever you go to an interview.
Yeah.
You guys know I'm gonna push you. It's not gonna work in an interview. How you interpret it, how you explain it, be your defining moment as far as saying, huh, this guy can't talk to certain people. He can't elaborate it like how we elaborate it. So you have to be the best engineer in the room, okay? Cool, excellent. So with that being said, walk up. Hold on, give me 1 second. With that being said, Zamir, walk Claude through how he would do this. And you can ask, hold on. If you need to, you can ask Kelvin for help because Kelvin did this multiple times.
All right. So I'm walking Claude through. He was saying the core. What's the original question? The core switches, or I'm just walking him through this part that we were just discussing, or the PCs being able to connect to the switches.
The access switch. You want to make sure that the access switch is learning the MAC of the PC number 3.
And we're doing this through command line.
Yes.
Okay.
So we verify PC3's MAC address right here. It was highlighted earlier, right?
Now we would need to show the MAC address table for that switch to see if it already recognized it.
Right.
My man. Exactly. Exactly.
I'm not sure the MAC address table. I'm not sure of the command. Kelvin, what is the command? Oh, well, they have it right here. Already
right
there.
here.
Okay,
So,
never mind.
show MAC address.
Show MAC address table. Okay.
Now don't get alarmed by it. You'll see me do these pipes where I'm honing in down on specific information. That's just me and the way I've done things over the years. But the command that you were looking at is basically will look just like the show MAC address, and you're gonna get everything on that switch.
And what port is connected to the
Right.
VLAN,
Right.
the type of, okay.
And so this is good, right? And this is where, and Zamir, this is where Kelvin comes in, right? Where you're going to ask for help. I don't, right? Me being the customer, right? And you troubleshooting my network, I do not see PC3, which possibly can be a service, providing a resource to my end users on this network. It's not being learned by switch 1. Kelvin, what can I do, right? And help Zamir out to start generating traffic to make sure that PC1 is being learned, even though it doesn't have a MAC address, an IP address on that endpoint.
You can send out a ping.
Without an IP address?
Oh yeah, with that IP address. I'm sorry.
All good, all good.
I mean,
What else can we do?
you can just cut the switch, cut the PC off and cut the PC back on to generate a BPDU.
What if I didn't want to do that?
Could you just send out a ping with all F's to send out a broadcast?
Claude, don't bounce it. Claude, don't bounce it.
Okay.
Yeah, you shut the port.
Nope, that's too easy. That's too easy, right? So what if so Kelvin, all right, Zamir, get out of the hot seat. Kelvin, you're in.
Okay.
I got your back, Kelvin.
That being said, so with that being said, right, what if this is a critical resource, right? We're working in the Department of Defense, right? We can't shut this down.
Right.
What are you going? So let's think about it. Let's dial it back, right? What initially, right? Let's say this is a Windows PC, doesn't have an IP address. What is it going to do? What packets is it going to send out to make sure that it can get an IP address?
A DHCP packet.
My man, exactly. Claude, I want you to go to the PC if you can. Pop the command DHCP on a CLI, and then let's go ahead and per Zamir's instruction, I want you to go ahead and let's look at the MAC address table, see if it learned that MAC address. Because again,
Zamir.
we're still at layer 2. We're still at layer 2.
What do I type in, Zamir?
Okay, so on the PC side, okay, command line, hold on.
So on the PC,
We want to,
we just made the PC holler out. So to see if the switch is listening. We just made it holler out for some DHCP. So the switch, we want to see if that switch is listening. So we want to see if that switch has learned.
so let's do, if I'm not mistaken, show MAC address table again, because we did say we had to do it on the PC too, to see if it's connected on the switch, or if it now, has learned it, which it now has a third, looks like it has learned a third MAC address.
Yeah.
My man.
The same one, it matches to the PC now.
Yep.
Mhm.
And so what do we send
100%.
out again? Oh, the DHCP.
Yeah.
Okay, I see it
Right,
now. DHCP.
right.
I just want to make sure I got how it's tied in with that.
It's all good. It's all good. It's all good. Because guys, remember, right? Sure, from your CCNA studies, you guys know if there isn't any traffic, right, on a port, so basically no electrical signals that are sent out from a source to a destination, right? What the switch is going to do, if it hasn't communicated in 300 seconds or 5 minutes, boom, we're dropping that off the MAC address table. Okay. So without bouncing the port, this is another method. We can just go ahead and generate packets, generate DHCP packets. Going to shoot out that broadcast message, right? Doing an ARC, right? So cool. We got it. Claude, it's all you.
All right. So we got a confirmation on the access switch that we have learned the MAC of PC3. Now, what we want to do is we want to check and make sure that all right, we haven't done anything with, let me see, we don't got no VLANs on here. Let me just check and make sure. Okay, so yeah, we have our VLANs on here. All right. So what we want to do is we want to make sure that our links to the distro, okay, our links to the distro, we want to make sure that for one, we can see that we got layer 1 and layer 2 up on those links there. And let me see, this link going to distro switch 20 gig 00. And we can confirm we got layer 1 and layer 2 there. And this switch going down to distro switch 19 on gig 01. We got layer 1, layer 2 there as well. Okay. So that's good. That's good. We do the same thing for the distro switches 19 and 20. And also here's another thing you can do. I don't know if we talk too much about this here, Command, but from that switch, we can also do a show CDP neighbors, and we should see distro switch 19 and 20. Okay, that's another way we can check and make sure that those switches are talking to one another. Now, could that been ran on the switch to find the PC? No. Okay, because the CDP neighbors by design is a Cisco proprietary command. Therefore, we got to have Cisco devices on the other end. Now, with that being said, there is a way to actually determine if we do have something on the other end of that switch at layer 2. And I don't think we talked about it too much, but let me see. Joe just slipped in here. Joe, you there?
Yeah, I'm here. How y'all doing?
How you doing?
Pretty good.
Do you remember the protocol to speak to a neighboring device using open source methods?
Yep, LLDP.
Exactly. So everybody, there's another term, and this is when you're in an environment where you're using something other than Cisco. You got HP, you got you got Hewlett Packard, you got Aruba, you got something else, Dell. You're utilizing LLDP, link layer discovery protocol, okay, which does the same thing that Cisco discovery protocol does. All right. But Cisco discovery protocol, CDP, is proprietary to Cisco. LLDP is open source to multi-vendors. Okay. All right. So let's get back to taking a look at our distro switches. So let's open up distro switch 20. And let's go in here. Let me see what this other putty window want to do. All right, so this here is distro switch 20, and we want to enable that. And let's just take a quick look at its layer 1 and its layer 2. Okay, so looking at the topology, we got gig 012, which we know is good because we checked that from the other end. All right, we got layer 1, layer 2. We got gig 022, which we can confirm here is good. Gig 023, which we can confirm layer 1, layer 2 is good. On the other side, we got gig 20 and 21, which are these two right here. So just at quick glance, we can see that layer 1 and layer 2 is up and functioning the way it should be on that switch. Close that out. And what we can do is we can confirm the same thing on distro switch 19. Okay. And just for quick reference, if you're out in the field, you can also probably do this. Show interface brief, pipe, include, all you want to see is the up stuff. Okay. So what we're looking at here on distro switch 19, we already know that 0112 is good because we checked, we had Zamir check that in the very beginning. 22 and 23. Oh, I grabbed the wrong thing. There we go. 22 and 23. We got layer 1, layer 2 up, and 20 and 21. Looking good there. Okay. All right. So we can just check for quick sanity. Let me see. Hold on. Let me get this.
Quick question, Claude.
Yeah, go ahead.
If we're not using gigabit 30 and 31, isn't it best practice to go ahead and shut those ports just for
Absolutely. Absolutely. You're looking at
yes, right
keys
there.
down here? Yeah, absolutely. Best practice, shut them down. Matter of fact, shut them down and stick them into a dummy VLAN like 999. However, you may see fit on site. Yep, absolutely.
Sir.
Calvin, you bring up a great point. So why is that a best practice?
I mean, because it's not in use and it would give like hackers access into the network.
Is that all?
I just know it's a security best practice.
Okay, you're an engineer. Come back with a little bit more, okay?
Okay.
All right, boss.
All right, you thinking about, Kelvin, you thinking about VLAN hopping and all that hacking stuff?
Yes, sir.
That's what you're thinking about? Okay, okay. All right, so we see here distro switch 19 and 20. And we see that we have some MAC addresses here learned dynamically. As you see again, I'm piping it to minimize all the unnecessary fluff information that not really concerned about. Okay. And guys, what we're going to do is I'm going to have one of you configure DHCP. Okay, because we are dealing with layer 3 switches here. I'm going to have you configure DHCP on one of these here 2 switches. All right. With that being said, let me see, Kelvin.
Yes, sir.
Tell me, what are the components I need to create a DHCP server on layer 3, on a layer 3 switch, multi-layer switch?
You're gonna need to make one of the switches a DHCP server, and the other ones are gonna be clients.
Well, the switches don't necessarily have to be clients because
Okay.
they're going to pass those DHCP unicast and broadcast on, you know, as they see fit. But when we are creating a DHCP server, for one, we need to create an SVI. Okay. And this SVI can serve as the default router when you get into the actual DHCP config itself. Okay, the default router. So, okay, quickly, Angela, you on there?
Yes, I'm here.
Give me a number, 20, 30, or 40.
Let's go with 30.
30? Okay. All right. So, ladies and gentlemen, that will be our lucky VLAN tonight that we will assign these PCs to, and we will create this server, this DHCP server for this specific VLAN to issue the addresses out. Everybody cool with that?
Yes, sir.
Okay. So let's take a look at something real quick. Do we got any VLANs? We should have VLANs on these distros.
Claude.
Yeah.
All right. I'm gonna start putting people in the gulag. So you're doing too much.
Okay. All right. All right.
So pop out of this. Pop out of this. Claude, you know we play the good cop, bad cop routine, so I don't even know why you're surprised. So, Joe, what's up, man? What up, Joe?
I'm good. How are you?
Oh, I'm good. I'm good. Excellent. So, Joe, we're doing this, like, I'm picking up where Claude left off. We're doing this DHCP deployment, right? We're using our core switch that's going to act as a DHCP server. How would we configure that?
All right. So we need a gateway. We need a pool.
Okay.
We need a DNS server. And I feel like I'm missing one thing. We need to define what addresses we're excluding from being addressed out.
Perfect. So within all those components, let's break down each one, right? Because we're all engineers. So
Right.
why do we need a gateway?
So we need a gateway that points to what device we're using to get out of the network to get routed elsewhere.
Perfect. Okay. And the DHCP pool?
So the pool is going to be the addresses that can be, well, from the subnet, I guess, that are going to be assigned or can be assigned to anything within this network looking for an address.
Okay. And the DNS server?
Same principle as the pool, basically what you're pointing to for the addresses to be resolved to name-wise.
Perfect. Is there anything else that we're missing?
The excluded address, for example, you would put your the gateway as an excluded address so that it doesn't get addressed out to any of the devices in the network.
So what can happen if we didn't exclude addresses?
You could end up with a situation with two devices having the same IP, and then that would just go into issues that would have to get probably resolved using ARP.
Wait a minute. So if both endpoints have IP addresses, you're saying ARP should resolve it?
Well, not that it would resolve it, but you would be able to detect the issue with ARP protocol.
Cool. Jay, you're still in the hot seat. Claude.
Okay.
Yeah, I'm here.
I'm gonna have Jay walk you through configuring that on switch 2. We're gonna do some packet captures and we're gonna take a look and see what happens if we don't exclude it, okay?
Switch 2. Let me see where you at. Where you at? You on the other side of the screen? Because we're still on the
We're
switch
on,
one
yeah,
side.
we're on the other side of the screen.
Okay.
Yep, we're
All
on
right.
switch 2. Switch 2 is gonna be that DHCP server.
Okay.
So Claude's gonna, Joe's gonna walk you through configuring that, and we're gonna make sure PC3 gets an IP address, and we're gonna see what happens if the SVI on core switch 2 has the gateway address, and we don't exclude no addresses. What'll happen? Okay.
Okay.
If it
Let's
has the same IP address.
you got to turn. Let me turn these on here. Let me see. Get that puppy warmed up. Is my mouse stuck or something? It's
Nah, because like I told you, I was troubleshooting that Aruba switch earlier. I think I'm still logging. Let me turn off logging. Hold on. I got you.
Yeah, okay, yep.
Yeah. Sorry about that. That's on me.
You got a huge file sitting somewhere.
Nigga.
Yeah.
All right, go ahead.
All right, so this here is warming up. Let's get at a minute.
Oh, Brian, by the way, you're next because before Joe, Joe being one of your senior network engineers, I need you being the junior network engineer to explain how we're going to connect to both sites and what's more efficient. Thank you, Brian.
Okay, voluntold, I guess, huh?
Yeah, this is Joe's first time joining us here.
Yes, I finally was able to make it. Sorry I'm late.
You got some
Oh, no,
time.
Well, we're glad you're here.
Joe, it's all good. We all got lives. It's all good. Just glad you could be here.
Yeah, you've been pretty
Absolutely.
busy. You've been pretty busy, that's for sure.
You did amazing.
I think we can actually keep this here network small, maybe down to like a /28 or something.
Brian, I hope you're ready. So before Joe being your senior network engineer, before she can implement anything, you need to make sure layer 1 and layer 2 is set up and good to go between both buildings.
I feel like you setting me up for this. And I feel like it's based around all this stuff that I just we gonna work with it. We gonna go with it. Mm-hmm.
Paul, stop giving them an answer. So Brian, what's the first step? How are we going to connect both sites?
We need to make sure that they both are on the same network.
Okay.
That's the first thing that I would say. In order to communicate with each other, we would need to change the local network configurations. That would be one thing. Like I said, same network.
Brian.
What's up?
OSI model. Why are you skipping?
Oh, we checking layer
What
1
do we
first.
need to do first? There we go. So what do we need to do first as engineers?
Check to see if if it's able to connect.
Okay. So we're going to get the MAC address of switch 2 and the MAC address of the core switch 1, right?
Correct.
And see if there's connectivity between the both sites, correct?
Yes.
Perfect. So walk Claude through it. Thank you.
All right, so what we're gonna do is go into that switch. And then you're gonna do show MAC address table. Well, hold on.
We on switch number 2, core switch number 2? Is that what you're talking about?
Core switch number 2, yeah.
Okay.
Show MAC address table. So it's not pulling anything.
Should it be?
Well, we haven't configured anything for it to learn it yet, right? Because you have to show interface. Oh, you already did it. Let me see that. Let me maximize this window first of all, because I'm gonna be blind in a few minutes. There we go. All right, so what's that connection? G3110 G31. Yes. 10. Three.
Let me
All right, so you have to bring those ports up on, well, basically configuring that switch so that it would actually be able, so they would be able to connect. Then
Okay,
try.
so
Okay.
so let's look at this. Let's look at this.
Mhm.
Uh, if we know right now on core switch, let me pipe this up. All right, so if we know on this here core switch, all right, you hollered out, what was that, 3-1? So we know in this core switch, layer 1 is good. We got a connection.
Layer 2 is down.
Right. So
So the switch would need to be bought up.
exactly.
So Brian, how are we going to do that? Nope. Brian, so how are we going to do that?
So you would actually need to go into the switch and go ahead and configure those. So go into switch 2.
Brian.
What's up?
Brian, the switches that we're using, core switch 1, core switch 2.
Oh, so
You're the
your
engineer.
distro switch.
You're the engineer. If we're talking about the OSI model, you being the engineer, you're designing this. So Joe can configure at layer 3 and beyond. What are we going to do at layer 1 and layer 2 to make sure they can communicate? Just gave you a hint.
That they have to be connected.
There we go. Exactamundo. That's the first step, right? Because
Right.
it has to travel through a physical medium, correct?
Right.
Perfect. Okay. So with that being said, you're the engineer. Walk Claude through it.
All right.
What
So
protocol you're going to use? Let's get our MAC addresses. Let's keep going.
So in order to get these two directly connected, they will have to be a part of the same network. So we would need to assign an IP address to both of these.
Layer 1. Let's think layer
Brian,
1 first.
Brian.
Oh, layer
Think
1. Gotcha.
Layer 1. Joe's got layer 3 for you. Layer 1 and layer 2. What are we doing? You just said the answer. We need to connect both sites. So what are we doing at layer 1?
Provide a connection to the that connects both of them directly. So connecting directly from core switch, that one doesn't have a number. Whatever that one is that you're on now, directly over the core switch 2.
Perfect. Keep it simple. Exactly just like that. So you want Claude to use any ports, or you want
It depends on the resources for the client. Do they mind about resources or not? If not, I'm picking the fastest one.
Okay, so me being the customer, hold on, Claude, before you connect both sites. Let me ask Brian a question, right? Because you're the engineer. Why do I need to worry about resources?
Resources, because if you take like the fastest route, and I'm gonna try to, hold on, let me back up before I say anything because.
Thank you. So keep going.
So
think about your answer. You don't have to answer it quickly.
You would want to take the fastest route.
Okay.
Cost wise.
Okay.
For connections. That is one other thing I'm thinking about. I'm thinking about spanning tree.
Okay. I mean, you're onto something, right? Because so guys, everybody that's listening, he's correct regarding resources, right? Regarding that physical medium, that cable, right? But Brian, I need you to keep going. You need to back this up, because again, whenever you being in the field, whenever we're having these design meetings, if you have an idea, you're going to have to back it up.
Okay.
So resources. Do you need help? I got you. I mean, you can talk through it like engineers.
All right. So in any instance, of course, the more resources you have, the more efficient your network will be. When it comes to resources, it could take a little bit longer to make the connection, if you
Mhm.
aren't using as many resources. But if you have enough,
Okay.
or if it doesn't matter, then, or if you have multiple, like enough resources, enough to compensate for whatever your network is, the fastest network, the fastest resource, or the more resources you have, the faster the network will be. So I'm trying to.
No, Brian, you did excellent. And we'll clean it up later, but I just wanted you to get the concept and everybody to get the concept, right? It's about resources, okay? So, Brian, we're gonna talk through this, me and you being the engineer, right? We're working for Joe and Claude, okay? So,
Okay.
right, let's say on that access layer switch, correct? It's a 24 port switch, correct? Each port is a gig port, right? Brian, you there?
Say it one more time.
Okay, so let's say this, right? And I'm still sticking. I want everybody to keep in their mind resources. Claude, I know you're gonna make this simple for them, but I'm hitting them with the technical portion, okay? So with that being said, right, Brian, I'm sticking to what you said about resources, okay? And making sure that we don't overrun it. If we have access switch 1, right? That's a 24 port switch, okay? Let's say it's for comparison purposes, it's a 100 meg port switch on each port, right? So we have each port is being utilized all day, every day, 100 megs up, right? It's being used exactly 100 megs of traffic is being pushed through that port on each port on a 24 port switch. And we have 2 uplinks, okay? So 24 port switch minus 2, okay? So that's 22 ports, right?
Right.
100 megs for each port, right? Including the 2 uplinks. And each port, right? Everybody that's in the company that's connected to that switch is running at full capacity, so 100 megs each. What's 100 times 22?
100 times 22.
2200.
2200. Hold on.
Yeah, you're right.
Yep, exactly. You're right. Yeah, you're right. So 2200, right? So what's 100 times 2?
200.
Perfect. So on our downlink ports, our ports that are connected to our end users, 2200 megabits per second, right? That's being passed up to the switch. We have an uplink, right? Uplinks that total up to, we didn't bring them together, it's totaled up to 100 megs each, right? With that being said, is all the traffic going to pass through those links? Yes or no?
Say that again.
If all the ports that are connected to end users total up to 2200 in our uplink ports, right? Our ports to our distro switches are 100 meg links, 100 meg ports, right? Is all the traffic that's coming from the end user going to be able to pass up, or will some traffic be dropped from that switch? Anybody can answer, by the way. Anybody can answer, by the way.
Yeah, I might need help with that one.
It's all good.
It's gonna be limited, right?
Joe, what do you think? Who said that?
It's me, Patrick.
Okay. Expound on that. What do you mean limited?
So if we have 2.2 gigs going into the switch and we can only pump 100 megs out, then there's a queue, right?
Okay, keep going.
So we'd have to set up some type of QoS for like calls and
Nope. Stop. Before you get there, I just want you to talk about what's going to happen if we don't set any of this up. What's going to happen to that traffic?
Yeah, it's going to get stuck. It's going to be like a line.
So it's going to be, the traffic is going to be dropped, correct?
Yep. Oh yeah, it's going to be dropped. Yep.
Perfect, right? No QoS, no anything. This is excellent. I want you guys to understand that, okay? Going back to what Brian said, right, about resources, right? Joe's gonna set up this DHCP server on switch 2. If we have, right, we have a whole bunch of PCs that connect at the same time. Everybody gets to work at 8 o'clock, trying to get an an IP address. That's a lot of traffic passing through just a 100 meg link that's connected from switch 1 to switch 2, right? Is there something that we can do to make sure that traffic is load balanced, right? That's a hint. Between core switch 1 and core switch 2. Angela.
All right.
So
Let me see.
I was,
Go ahead.
oh no, you go ahead. I was just saying that the word load balance kept popping in my head. I guess just looking at it, in order to have like a fail safe or anything like that, to like say for instance, if traffic is dropped somewhere else, the load has to be picked up or have another route to go in order to make the connection or to have that same, like if you can't go one way, go another way around or take another route or the fastest route possible in order to not drop traffic. That's what I was thinking when it came to load balancing.
Okay, no, that's not. Let's stay on track here. You're talking about paths. We're at layer 2 in that spanning tree. We're talking about load balancing. Okay, so Angela, what can we use between core switch 1 and core switch 2?
So
to make sure traffic is load balanced and the link doesn't get overridden with resources.
First, I'm gonna say something that's not on what you said. We can actually you can actually use like a SFP module to actually bring the speed up so we don't have that kind of problem.
Yeah, true, but just for this scenario. What can we do what can we configure between core switch 1 and core switch 2? So that resources don't overrun on those links.
So I'm kind of fry on this. Give me a few seconds.
It's all good. It's all good. Again, I just want to load balance the traffic so that one link isn't overridden. Kelvin, what do you think we can do?
Oh, we can use some of the channels.
You can go ahead. Create some port channels between the two switches or ether channels between the two switches.
So, okay, so Kelvin, what would that do for Joe whenever she configures her DHCP server?
What would that do for Joe for when she creates the DHCP servers?
Right. What'll that do for the traffic?
Oh, it'll load balance the traffic. So if it'll split the traffic up in between the two connections between the switches.
Exactamundo. Perfect. Okay, so Kel, you're still in the hot seat. Claude, I'm gonna let you walk them through this. I told you I gotta head to the grocery store, but you guys are still connected to my PC. Can still play around. I'm gonna disconnect. Guys, great job tonight. You guys are still gonna be working with Claude. I'm just gonna disconnect for now, okay?
Okay.
All right, folks.
Thank you, David.
See ya. Thank you.
Appreciate you.
Let me see here. All right, so we're going to go ahead and we're going to connect. Gig 0, 1. Let me see what other I got. And let me connect another one. Come on, get that off of there. No, I didn't want to do that. Okay, so basically what we got here is we got our 2 links, which right now are seen as single individual links by a spanning tree. But in the conversation we just had, what is our intention to do with these 2 links?
Make them so with a port channel or ether channel, multiple links are seen as one logical link.
Right. So let's do this. All right, that's that switch. All right, so let's see here. We got core switch number 2. All right,
Right.
Kelvin, walk me through
All right, so,
bundling these here two links.
So first we're gonna have to actually create the port channel. So you'll enter the command configuration config T. All right, so you'll type interface PO1. If we're just gonna make that port channel 1. So yeah, that's it. I don't
Can I say something? Because you don't actually, you have to select the port before you actually create the port channel.
I thought you had to create the channel first and then add the ports to the channel.
Yeah, you can do it vice versa, but usually.
But yeah, he's right. Best practices, you get the individual links geared up first.
Okay.
Yeah.
So you can just hit type in, I guess.
Mm-hmm. Or we could just back out one.
Yeah, back out. So configuration terminal, interface gigabit 0/1.
Mm-hmm.
Switch port mode trump. And then channel group 1, since it's going into port channel 1.
What we missing?
Can I say something again?
Oh,
Claude?
the protocol is LACP.
Okay. No, that should be active. My bad.
Oh, my bad. I'm sorry. I forgot it's
You have to put the mode.
Yeah, there we go.
Just for mode active. Okay, I'm sorry about that.
No problem.
And then we'll do the same thing for gigabit 1/1.
While you type in, Claude, I have a question.
Yeah.
Is that the best practice?
To do the individual ports first?
Yeah.
Yeah.
No. To do like by port instead of by range.
Well, because of the way these interfaces are, your gig 0/1, they're not continuous.
Oh, okay.
If it was 0/1, 0/2, then the range would be ideal to use in that situation. But because it's 0/1 and 1/1, there's a bunch of ports in between it that we're not going to be utilizing, that will get caught up unnecessarily.
Yeah, right. I didn't see the interfaces.
Okay, so what we're looking at is show run interface. Well, you know what I need? What I really need is some logging synchronous on the console. Show run interface gig 0/1. All right, so this is what we're looking at here. Is this what you're looking for, Kelvin?
Yes.
Are we missing anything?
Switch port mode. Got 1 GB. Trump auto negotiation. Channel group 1. I'm thinking it's right, but if I had to take a guess on the native VLAN.
No.
Okay.
So we're forming trunks here, right?
Right.
Okay. Let me see
Switch
if
port
this,
mode.
let me see if this rings a bell for you. Ringing any bells yet?
Allow VLAN.
Ringing any bells yet?
I'm sorry, it's not ringing any.
Okay.
Okay.
So basically, we got to specify which VLANs we're going to service going across this trunk.
Okay.
Sound familiar?
Yes, I'm sorry. It's been a while.
I should have put commas in there. Okay, hold on. I know Joe's sitting back like, I'm ready to do this DHCP.
No, this is good review. I'm enjoying it. It's good.
Okay. All right, so let's go, and what we're going to do is we're going to go take a look at the other interface. Show run interface. You know what? I'm sorry. Hold on a second. Config T line console.
Line con 0.
Yeah, there we go. Log sync. Okay, so for some of y'all guys, y'all newer guys, this here command here, when the Cisco iOS likes to spit out all this little messages and things like that, it gets you kind of jacked up as far as if you're in the middle of typing something. What this here logging synchronous does on the console is it actually allows you a new line so that you can continue typing without having your typing jumbled up in with the syslog messages. Okay, so that's what that does.
This took me way back to routing and switching in college.
Mm-hmm.
I got a whole notebook full of just that line con 0, line VTY,
Yeah,
like all of that stuff.
yeah.
All this makes sense.
You always forget about it until it starts to annoy you real bad.
Exactly. Matter of fact, I'm about to go back and do that with all of my my virtual environment. Because it gets me every time.
Yep. All right, Calvin. So this here is our other link. So what we want to do is we want to add that same line onto this one here. Do you agree?
Yes.
Okay.
And when we finish that, I usually just always run the command show port channel summary just to verify.
Yep. I got one with the commas in it. There it is. Oh, Claude, come on now. You know better than that. We got to talk about something here. There we go. Gig 11. There we go. All right. All right. That look good there?
Yes.
Okay. All right. So you said you wanted to do a show.
Ether channel summary. I mean, port channel summary. I'm sorry.
If the channel summary is right, is the that's the right syntax.
Okay.
If I can spell, let me see, summary 1U. There we go. All right. So as you know, we're suspended, of course, because we got some stuff that's not on the other side. Well, you know what? Duh. Kelvin, we ain't even put the port channel together yet. We just primed the individual links. So we got the port channel that we put that you said earlier, but we stopped in the middle. But the port channel has been established. Oh, come on now. Come on. And I cannot.
Hold on one second. I gotta let my dog in the house. Hold on.
Yeah. I hate to open up all these windows.
All right, I'm back. Sorry.
All right, there go our port channel right there. All right. So, of course, we have these suspended links in the bundle, which is understood because we're not complete on the other side.
Right.
So we're suspended here. And we got a suspension here. No, that's not even our.
So shouldn't 1/1 and 0/1 be the only two interfaces in that port channel? Oh,
Yeah.
no.
No, you're right, because I'm trying to figure out where this 1.3 is coming from.
Yeah.
So let me see here. Yeah, that must have been something there that was left by something else a long time ago. So we are going to get rid of that. Let me see. The command to wipe out an interface, I think, is default. Interface. Is it interface? That might not be it. That might not be it. Interface, there we go. G3. Now what that should do. Yeah. So that basically takes back when you can either negate all these commands individually, or if you're thinking about it, you can quickly default an interface and just wipe it out completely.
Okay.
So just remember that for real world applications. And we can actually do a show run interface GI 1/3, and you can see now all that stuff is gone.
Okay.
So when we go to take a peek at the ether channel summary that you mentioned earlier, you can see that
1.3 is gone.
1.3 is gone, but how many interfaces?
It was two of them. That was so 1.3 and 2.0 were both in that port channel.
Was it?
Yes.
All right. So what we're going to do is we're going to do that again. We're going to do that. Let me see. Interface GI 2/0. I'm going to tab up because we'd rather spend 40 minutes tabbing up than just retyping the command. Default interface and wipe that out. That's good. All right. Now let's go and check that summary again, and that looks more like it. Okie doke.
Yes, sir.
All right. So let's go to core switch. Oh man, Dave's going to kill me. I don't have access to his taskbar down there. It's out of my screen because these windows are already open, and I'm opening new ones because I can't see.
Oh, he must got multiple windows connected.
Yeah, he does. So his processor is gonna get bogged down because he's gonna have like 50 million 11 windows open up down there with putty screens. All right, so we're on core switch number 1, and what we want to do is we want to match the same thing on the other side. So we want to do a config T interface. What is it? /0. All right, go ahead and walk me through. Uh-oh. You there, Kelvin?
My bad. I hit mute by accident when I let the dog.
You good?
So configure external interface 1/0. So switch port mode trump. Switch port trump allow. Let's go ahead and put the allow VLANs in, I guess. VLAN 10 20, 30, 40, and I think it was 50.
Mm-hmm.
And did you have 99 as well?
Yeah.
Okay.
Get them spaces out of there. All right, Claude, come on now. Put that comment in there. All right, there we go.
And then channel group 1. Meter mode active. And do the same thing on gigabit 1/1.
Okay.
I'll switch port mode with Trump.
Come on, I know that command is in here. See, here we go. See, this is that BS I'm talking about. We spend 45 minutes going up. Truck. What am I thinking about?
Channel group 1. Would you have to, I can't remember, do you have to perform a no shut on port channels?
We can. Yeah, we can. Once we get the PO up, we can do that.
Okay.
Let me see.
Interface, VLAN, yeah, CONFI.
I think we got to actually create the port channel on this side.
Yeah, so interface, PO1. Yeah, I think that was it for that command to create the port channel. So I guess, yeah, show you the channel summary. Yeah, so it's a D because it's down, so we probably have to perform a no shut.
I think we need to get rid of these extras.
Oh yeah.
So that's 2, 3,
then we put
3-0.
1/1 is not in there.
1/1. Damn, what did we do then? I know I put something. Hold on, I know I did 2 of them. Hold on now.
Did you specify the channel? Oh yeah, you got the channel group.
There's 1 right here.
Switchboard.
Ain't that about a bitch? And they go 1-0. All right, so let me see.
Hey, leave it to Claude. Like you having a good old time in here.
Yeah, something. So let me do this. Show run interface. GI11. Get rid of that slash. Port channel. Oh, it was already selected for something else. That's why it never showed up. It was already committed.
It's saying it's in channel group 18.
Yeah, so that
you
must be some old stuff.
And you just go put no channel group 18 mode active to take it out of that.
Yeah, we can do that. No interface.
No, you got to go into the interface GI1/1. Well, G1/, yeah.
Yeah, see, I'm let me see, what you say? No
channel group 18 mode active, and I think that will remove that command.
Let me see. Okay. Because I would have just defaulted it. No
And then you
channel group mode active. No, channel group 18. Channel group
18.
18.
Yeah, 18.
All right. All right, so that should have left us with some stuff that we could use. Yeah.
So now just have to put it in there, put it in that channel group.
Yep.
And if you want to
get rid of this description.
I was about to say get rid of the description or change the description.
Interface, Claude. We up that. There we go. And channel group
One
mode act. All right. Now we had some other stuff in there too. What was it? There was another one in there.
It was
30.
Yeah.
No, we just put 2.1. We just put 1.1 in there, which means if we did an ether channel summary, we should have 4 ports in there.
Right.
So we gotta actually just go out and blow out these two here.
Yeah, 2, 3.
2, 3, and 3.0. Somebody remember that.
All right.
Interface GI 2/3 default interface GI 2.3.
That's 2, 3.
2.3. And what was that? 3.0.
Yes, 3.0.
All right. See, this is what happens when you working off of on top of older configs. And actually, this happens a lot with actual gear. I'll do this a lot. I'll have my gear running, and I'll have something up that I did 4 months ago. And I'll come in one day with a bright idea to do something else and just start going at it. And I'm like, what's jacking me up? And realize I done had some DMVPN in there or some BGP configs in there from way back whenever. And it's just good to clean that stuff out. There we go.
All right, so I guess we gotta go perform the no shut on that port channel.
Yeah, we could do that.
And we had to go to the other side and
Spell it right. THERCH. All right, so there we go. Okay, so we need to actually confirm all right, so that ether channel is up, port 1. What else do we need to confirm? Speaking of trunks and all the other good stuff. We can confirm these here trunks going through here, don't we?
yes, sir.
All right, so let me see here. Access switch. Show run interface gig 00. Looking like we need some stuff on there. So switch port, trunk, allow VLANs 10, 20, 30, 40, 50, and 99. All right. Let's take a quick look at gig 01. And that got nothing on it. So this is what we want to do. And Brian and everybody else who's just getting into the business, this here is a quick real world situation where you can just mimic what you have. And what you do is you just copy, open up your new interface, which would be gig 01. Paste everything in there and keep it moving.
Hey, look, I like this kind of stuff. Yeah, I wish I could have copied and pasted the whole manual from security.
Now the thing is, when you're creating these trunks going across your network, that's what you'll do in the real world to save time. You'll have your little notepad sitting on the little corner of your screen somewhere, and because all of them, they're all trunking, they're all the same pretty much. You just go ahead and just copy and paste it, copy and paste it, copy and paste it. You know. So show interface.
I think one of the things I want to start getting into is like, say for instance, because there's a way to do it, like where you could actually create code that will allow. So say for instance, like security onion, if it'll config up to a certain point, then so it will be like 2 sets. You would config all the way up to the point where you have to put your own configurations that you need in there to be specific for your own system.
Yeah.
And then there's the second set of code where you keep continuing code like that in steps. So that's one of the things that I want to learn, because it would make life a lot easier for certain things. So it happens.
All right. So we need to take a closer look at this here access switch, right? Now, earlier this evening, I asked Angela what was his number that he chose between 20, 30, 40, 50. If I remember, he chose 30, correct? If I'm correct.
That's right.
Yeah, he chose 30.
Okay, so looking at this here access layer switch, port gig 1/3. Do we got a problem right now? I'll spell it out a little bit better. Take a look here. That's our port connected to.
Yeah, we got to move that port to 30.
Yeah. Okay, so well, I know Dave gonna be mad at me because he really want y'all to be working for this right here.
What switch are we on now? Distro switch?
Yeah, this is the access switch connected to PC number 3.
So you would go to interface 1 gigabit 1/3, and then you'll go to type in switch port mode access, switch port access VLAN 30.
That's it. So basically what we're doing is we're trying to clear the way for Joe when she drops her DHCP stuff on here, trying to minimize any possible hiccups along the way where that traffic could be impeded. That makes sense?
Yes, sir.
1/3. All right, so that interface gig03 connected to the PC, and we'll just do this for good measure. No, that's not what I'm looking for. We'll just call it that. All right. Okay, so I think we are good to go. Let me check and make sure. So we are trunked. Show interface GI 0/1 trunk. All right, so this is a command y'all probably seen before. If not, this is how you can quickly check a trunk port to make sure you got your VLAN set up on it properly. Okay, so here we're going to be passing 10, 20, 30, 40. No, allowed on the trunk, 10, 20, 30, 40, 50, and 99. There we go. I'm gonna do the same for the other side because that's G01. And 00 should look identical. Yeah. Okay. So we open up core switch number 2. Let me see if I can. Did y'all screen just get small?
Not mine.
What did I just do?
Okay.
All right, let me see. Zoom ratio fit the window. That's what I'm looking for. There we go. Okay.
Yeah, I think you got to go up to the view options area and change that.
Yeah.
Mine is set to fit the window.
Yeah, what I did was I shrunk it down to 50 cent and I looked at all those 50%. And I'm looking at all those windows at the bottom.
Everything looked like 2.
So let me try to close some of these excess windows down here. That one can go. That one can go. This one can go. That can go. All right, core switch 2. There we go. I'm gonna go back to fit the window. All right. Okay. Joe.
Yes.
Are you ready?
Yes.
Okay. So go ahead. Let me see. Can I turn this over to you? Let me see here.
I'm
Yeah,
on my
but-
phone. So
You on your phone? Okay. All right.
yeah.
All right. So you're gonna be that Jedi and just rattle off the top of your head. I got you. I got you.
We're
All right.
gonna go with it.
I'm on core switch number 2.
All right. So we're gonna config T.
Mm-hmm.
Oh, let me ask you first. Do you guys already have like an address scheme, or are we just coming up with something else?
Come up with it. Come up with it.
Okay.
But let's
Okay.
keep it small to about
Yeah.
maybe a
You said
slash. Yeah.
/28, right?
Yeah. There we go.
All right. So config T,
Mm-hmm.
and we're gonna IP DHCP excluded address,
Okay.
and I don't know. Can I just stick with like 192.168?
Yeah,
That's fine?
yeah,
Okay.
keep it simple. Yeah.
All right, 192.168. We'll do 1.1. We'll exclude that and that'll just be our gateway.
Okay.
All right. So
How far are we taking it out?
because
we only got what, 15, 14 addresses. So
14
Right.
addresses.
so how many you want to leave? Exclude out?
we can just exclude that one. You want to just exclude that one since
That
it's such
one?
a small subnet anyway.
Okay. All right. So we're gonna leave .1 out.
Okay. So IP DHCP pool. I don't know. I guess we can name it lab or something. I don't know. It doesn't matter.
Here we go. We're gonna name it Joe. There you go.
Okay. All right. So we'll do network and 192.168.1.0 and subnet mask can be 255.255.240. All right, and then I think it's default router, right? Yeah.
Mm-hmm.
And then 192.168.1.1.
Think about it.
Wait, are we not going to just use the .1 as the router?
I'm gonna do like Dave. You asking me or you telling me?
I was gonna just go with that.
Okay.
The .1. Yeah.
All right. Default router .1. We good?
And DNS server.
Well, we don't even got one hooked up, so that won't even really
Okay,
apply.
so we don't need to do it. Okay.
Yeah, so we good there.
All right.
So do you remember how to confirm your pool?
You can just do show run.
You could, yeah.
And you could do pipe include DHCP or pipe begin DHCP, whichever.
Probably begin, because include's going to be real stingy as far as what
Mm-hmm.
Oh, Claude, what protocol is that?
Your fingers got happy.
All right, DHCP. And here we got Pool Joe. Yep. Network 192.168.1.0/240. Default router of 1.1. All right. The other way we can do is show IP DHCP. What is it? It's not bind. Pool. It should be pool. Yeah, there we go. That's the other way we can confirm it.
Mm-hmm.
Pool Joe. There's 14 addresses, because as we know, we can't do nothing with the network nor the broadcast.
Correct.
So that's 2 taken off. And here is our given range, but we know that one's going to be excluded, which is the 1.1.
Hey, Claude, I learned about this.
What's up? Yeah, you should know all
But
about.
I learned about.
Yeah, you should know all about pools, and with your wireless link over there, setting up 14 networks in the house. You should know all about this.
I got a lot going on.
Mm-hmm. All right, Joe. So what else do we need here?
In regards to
configuring to make sure DHCP functions properly.
So let me ask you this. Is this going to be for both PCs or is this just for PC? What is that for?
Ultimately, it's going to be for both PCs.
Okay, so then we need to
set up. But right now we're just looking at PC
for PC 3.
Yeah.
Right. So since that one is in a different network, we have to set up the DHCP relay.
No, that's not in a different network.
Oh, it's not. This is all just one network. Okay.
Yeah, because all this over here is all layer 2. So we ain't even. Okay. Mm-hmm. So I'm gonna tell you this. It's going to be centered around this IP address right here.
All right. So we just need to set up our SVI then.
There you go. There you go. config T, interface VLAN.
What is it? Are we doing 30?
Yes.
And so
IP. Give it to me. What is it?
it's 192.168.1.1. And then .240.
Show. So everybody in the room, when we assign IP addresses to switches, SVIs, we're dipping into the layer 3 realm. Okay. And what we need to do is we need to bounce that.
So no shut.
Yeah.
Do we have IP routing enabled? Is that why this might still be down?
Routing.
Still down.
Let's see, what are we missing?
Can you try to shut it down even though it's down and bring it back up again to see?
Say that one more time.
Can you try, even though it's down, can you actually shut it down and bring it up, bring it up again?
Okay. What we got going on here?
I'll say that VLAN 30 is already it was already created on here prior to.
What? There are no VLANs on this.
I'll say that's interesting.
The hell out of here.
So then you got to go create all the VLANs.
Transparent. All right, this is what I'm gonna do. I'm gonna cheat this. Let me see if I can.
Those are the questions Dave was going to ask us.
You say that was what?
Those pretty much was the question is going to ask us, like why the VTP is not actually.
Yeah, you know, I'm sitting here thinking and knowing Dave, he probably wanted us to use this particular switch for that very reason. Let me see if I got core switch number 2.
There was a couple monkey wrenches in there somewhere.
Yeah, that's how he do. That's how he do.
Come on, we engineers.
Mm-hmm. All right, so let me cancel that. So enable show VTP status. He got that transparent too. Yeah, so he not having any of them. Okay, not a problem. All right, Kelvin. All right, so this is what we're gonna do. We're gonna go. Yeah, he jacked us up real good. I see. He don't even got VLANs on that one. Okay, which makes me wonder about the core. Or I should say the distros. Do I got a window for the distros down here? I do not. All right. So this is what I'm gonna do. I am going to quickly core 2. VLAN 10. Name native. VLAN 20. Name exec. VLAN 30. Name finance. VLAN 40. Oh. Facilities. VLAN 99. Management. Ten, 20, 30, 40. Yeah. You know, I hate to say this, but I missed 50. But that's fine. So you see this, Joe?
Yep.
All right.
There we go.
Let me go ahead and do this to the other core switch so they can actually traverse over there as well. Stand by.
All right.
Damn, David. See, he always playing bad cop.
Oh, so you're the good cop?
Yeah, that's what he always says. I'm the good cop. He says, I give up stuff too easy. Execs. VLAN 30. Name. Finance. VLAN 40. Facilities. I'm gonna skip over 99 and play dumb. Skip over 50 and play dumb, I should say. All right, so the other core, Had no VLANs, and now voila. Okay. Okay. All right. So just for giggles, nothing yet. All right, let me do this. Let's do PC. There we go. Uh-oh, look at that. Let's confirm. There you go, Joe. DHCP bind has issued a 1.2 address.
Perfect.
All right, everybody. Did everybody catch all that?
Yes,
So,
sir.
so we started off, had to, very beginning, Zamir had to confirm that the access switch was learning the MAC address of PC3. Okay. Then we had to go in and we had to make some trunk ports. Let me see, what else did we do? We went ahead and we connected the 2 core switches, tried our best to clear the way for Joe so that she wouldn't have any packets impeded when his DHCP went through to issue this here address. So we found out that we had some ether channels that we had to clean up, as well as we had to create some ether channels. Then we found out a big issue when we had our VLAN, our SVI that was in a down situation. Okay, and it was in a down situation because we didn't have VLANs configured on any of the core switches, thanks to David probably. So once we got that taken care of, you know, these are simple tickets that you could probably see if you ever work in a NOC. Joe, you could probably attest to that kind of stuff there.
Yep.
And, you know, you go in, assess what's going, you got your methodology of, you know, trying to figure out from point A to point B what's happening. And like I said earlier, what we were trying to do was we were trying to clear the road. We were trying to clear the path for Joe's DHCP deployment off of core switch number 2 into the network, getting the PC3. And that has been accomplished, and it has been verified with the DHCP bind command. Okay. This is where every DHCP server keeps a record of what it issues. Okay. And that's what that is there. All right. Does anybody have any questions? And we would literally go through the same process, and we won't do it tonight, but we would literally go through the same process on the right-hand side of the screen where PC4 is attached. And we would make sure that all those trunks are in the proper place. We would make sure that access switch is connected to the proper VLAN, okay? And clean up any ether channels that we may need, you know, make sure we got the proper VLANs allowed through those trunks, and set this here PC up to receive IP, and DHCP bind would probably have a .3, a 1.3 issued when that's all good. So anybody have any questions, any concerns, any thoughts? If not, it was good to have everybody on here tonight. Good review, layer 2, good introduction to see DHCP in action with an actual Cisco device, and appreciate everybody coming. Y'all did well. Y'all did well.
Appreciate
Thank you,
All right,
Cloud.
appreciate
thank you.
it. This is
Thank
a
you,
Right,
sir.
good
thanks,
session.
Claude. Appreciate it.
Thank you.
Absolutely. All right, so I'm just gonna sit here and wait for Dave when he gets back. But yeah, we'll catch y'all on the rebound. I don't think Dave actually recorded this, so there
It's
may
recording.
not be.
Yeah, it's recording
It
right
is?
now.
It's
Okay.
recording.
Okay. All right, so y'all know the deal. Y'all probably will see a tag come up somewhere along the lines in the middle of the night, you know, because
Yeah, it'll be there.
yeah, him and I are bumping into each other about 2 a.m. doing individual labs or something like that.
I
Yeah.
think y'all get sleep.
Well, you know, I got all the time. My main job is
Fine.
taking my main job is taking my little girl to school and picking her up. So everything in between that is, you know,
Okay.
yeah, it's either Netflix, I'm out at the pond throwing rocks, you know, napping or something. You know what I mean? So
Okay.
long as I'm in carpool line, that's all that matters. At the right time.
Pick up, drop off.
Pick up, drop off, and I got to bring a snack. Yep.
All right, well, y'all have a good night.
All right,
All right,
good
you
night,
too
Cloud.
now.
Good night,
All right.
everyone.
Take care.
Have a good night,
Have a
y'all.
good one.
All right, bye-bye.
Bye.